This is the question given in one of the popular online test series. In my previous videos also I suggested we should not promote misconceptions, because what student will think, because he trusts us. Okay, he trusts the brand and he may feel, okay, for this question we have to do like this, and for that question we have to do like this, and he will try to remember everything, and at the end he will not be able to do correct thing in the exam. Okay, means in recently when I launched some videos on synchronous machines and induction machines, I got some friction, because somehow faculties they were saying completely 50 Hz is fixed, and for 2-pole machine it should be synchronous speed should be 3000, for 4-pole machine it should be 1500, for 6-pole machine it should be 1000 rpm. So by repeating all these, and people are feeling okay, 1500 is the synchronous speed, it should not reduce. Okay, so if it reduces somehow because they are kids, okay, they are connecting it to maybe stability, or they are connecting it to something else in transient analysis. Okay, so synchronous speed, that's why I never said this in my class. Okay, you can check my class notes. Okay, I hope it should be there in the Telegram group. Okay, so if you check my class notes, I never said that this should be 1500 rpm, and for 2-pole machine it is 3000 rpm, something like that. I never said that, because depending upon the frequency everything will change. Okay, so anyway, point here is a 3-phase 50 Hz 16-pole generator with connected winding. Actually star should be there here, it's a small typo, it's okay. Star connected winding has 144 slots with 10 conductors per slot. The flux per pole is 24.8 milliwebers, is sinusoidally distributed. Sinusoidally distributed in the sense there are no harmonic component in the operating flux. If the coil is full pitched, then the line voltage given, the line voltage is numerical question. Okay, so point here is, the moment they say full pitched, I said in my previous videos also of synchronous machine at no load conditions, the moment they said short pitched by some angle, pitch factor should be calculated. Short pitched by some slots, pitch factor should be calculated. Or coil span is these many slots, pitch factor can be calculated. But if they say full pitched, or if they don't give any information about short pitching angle, we have to consider pitch factor as 1. We need not calculate. But what about the distribution factor? Distribution factor, we have to find ourselves whether distribution of the windings is possible or not in the machine stator. Okay, so distribution factor, about the distribution factor they don't give information, they need not give any information, we have to calculate ourselves about the distribution factor. Now distribution factor in the sense, Q has to be calculated first, is going to be slots per pole per phase. So how many slots are there? 144. And how many poles are there? 16 pole into 3 phase. Okay, so slots per pole per phase is going to be 3. What does it mean? For example, out of total number of slots per pole, per phase, 3 slots are available. So in those 3 slots, my winding should be distributed or not? Yes. Okay, so means phase A, slots per pole per phase. Okay, so slots per pole per phase, and all phases should be lying in the one pole area. So 3 slots should be given to phase A, 3 slots should be given to phase B, 3 slots should be given to phase C. So here winding is distributed winding, KD has to be calculated. They considered without KD, which is wrong. Okay, so how much is KD? KD is going to be sine Q gamma by 2 by Q sine gamma by 2. Okay, what is gamma? Slot angle. What is slot angle in electrical degrees? How many poles are there? 16. Per pole, how much is the electrical degree? Per pole 180 degrees divided by how many slots are there? 144. Okay, so slot angle is going to be 20 degrees. Now let us calculate KD is sine 3 into 20 by 2 by 3 into sine 20 by 2. Okay, so is going to be 0.96, has to be considered. Okay, now let us try to calculate E, induced voltage per phase, is going to be root 2 pi f pi number of turns connected in series per phase into Kp Kd, is going to be root 2 into pi into frequency 50 they have given into operating flux 24.8 24.8 milliwebers into number of turns per phase. We have to focus. Now how many slots are there? 144 slots are there. You have to visualize, okay? Total 144 slots are there. In each slot, how many conductors are there? 10 conductors per slot. So means total number of slots multiplied by in each slot conductors will give you total conductors. Total conductors by 2 will give you number of turns, by 3 will give you per phase, into pitch factor is going to be unity because full pitch coil, into distribution factor is going to be 0.96. Okay. So this will give you 1269.12 volts per phase. Okay, so how much will be line to line voltage is going to be root 3 into 1269.12 volts is going to be 2198.12 volts. Okay, so conclusion is very simple. Of course their answer is wrong. They said that range is 2286 to 2290 and answer is 2288 point something, but answer should be 2198. Okay, so conclusion is very simple. What is that? About the distribution of the winding, they don't give any information. Okay, we have to find ourselves whether distribution of the winding is possible by calculating slots per pole per phase. Okay, so let us see other problems.